Hello everyone, let's get started with this PCB designing course on Easy EDA. First of all, in this session we are going to study about the basics of PCB. It means for those who don't know at all what is printed circuit board and some very important concepts related to the PCB. Okay, what is PCB or what is printed circuit board? Let me answer this question first. We all know that a circuit can be created like this. You might have studied this kind of circuits in your school studies as well as you have seen it on many web pages or websites. A circuit usually consists of a power supply and some electronic components connected with it. On a paper, the circuit looks like as shown in this slide. But when we have to actually manufacture the circuit to use in real life, we need to give a solid and concrete form to it. It cannot be just on paper or some interconnection of some electronic components, and for that sake we need to create a PCB or printed circuit board out of this circuit. So as per the definition, a PCB is the best way to materialize and manufacture the circuit. We can define PCB as a best way to materialize a circuit. Okay, now what this PCB is? We have seen the PCB board in the last slide. But what this PCB board is made up of? What this board is actually? This PCB or this PC board is actually a substrate. It is just a non-conductive material and there is a thin layer of copper deposited on this substrate. The thickness of the copper layer is of 35 micron. As shown in this picture, we have single-sided and double-sided PCBs. A single-sided PCB consists of a copper layer on single side of this PCB, whereas a double-sided PCB consists of copper layers on both sides of it, as shown in this picture. Simply, copper layer is deposited to single side for single-sided PCBs, copper layers deposited to both sides for double-sided PCBs. Blank PCBs can be purchased from the market. We can purchase these PCBs in different sizes and shapes. We can purchase bigger PC boards and cut them to use as per our requirement. The substrate, which is the base material, is usually a fiberglass. There are other materials also, but today we are going to discuss about fiberglass because it is the most popular one. Technically, it is called as FR4. This gives a solid core to the PCB and it gives PCB a great rigidity and the thickness, which prolongates the life of our printed circuit board. There are also flexible PCBs built on flexible high temperature on plastic. This kind of PCBs can be used as connectors in mobile phones and in many places. Usually that we do when we are creating a project, we use this FR4 fiber material. When we are doing DIY projects also, we will use fiber material PCBs. Not only in DIY works, in many industrial works, the FR4 PCBs are used. The board thickness also varies usually from 0.8 mm to 2.6 mm, but typically we use 1.6 mm thickness PCBs. On this 1.6 mm thick board, there is a 30 micron copper layer on both sides on a double-sided PCBs. On a single-sided PCB, the copper layer deposits on the one side only. So the PCB, when it is made at home by using a DIY method, looks something like this. You can see the electronic components soldered on it. All the connections among the electronic components made from the back side of this PCB. So what we do is, we draw a particular circuit on this PCB using a marker or something. Then we undergo the PCB through chemical process called as PCB etching, in which what happens is all the copper except those onto the tracks is completely removed. And the next process is drilling. As you can see, there are minor holes on this PCB. After drilling, we place the components in the holes and then we solder the components to finish the system. A soldered DIY PCB looks like as shown in this slide. So let's study some concepts of PCB one by one. First thing is solder mask. We have to understand what is this solder mask. It is the layer which is placed onto the copper tracks. If you can see this PCB, is there any layer onto the copper tracks? No. We can literally identify and see this is the bare compound. But on the PCB like this, we don't see a copper track. Instead, there is a copper track, but it doesn't look pink, it looks green. So this solder mask is a mask or layer of a material which is usually a color insulating which is applied onto the tracks. It gives PCB its color. So on a copper track it looks like this, and on a bare board it completely looks green. So on copper the color is a little bit light here, and on bare board it looks dark. There are red, green, blue as well as black solder mask colors are available. Depending upon the manufacturer, they may provide some additional colors also. The purpose of this solder mask is to protect the copper part of the PCB, because if a PCB is used like this in a hostile environment or in an industrial environment, it will get oxidized easily and the tracks will lose its strength, and the track may cut, or they may also get oxidized and lose the connectivity. Because of the solder mask, the copper tracks are protected properly and the silver mask is placed everywhere except the pads and holes for solderings. So pads are those for surface mounting devices and the holes are for through hole components. Next, what you can observe onto this any kind of manufactured PCB is what is called as silk screen. Can you notice something in this white color onto this PCB? That white color marking is called silk screen. So this silk screen is a white ink over the solder mask. It is there for identification of the components, because what happens is in this kind of PCB we don't have anything for identifying the components, and we have to rely on to our schematic and the layout to identify where we have to place the components. But in a manufactured PCB, to get a proper idea of where to mount components, there is a silk screen printed. Silk screen gives an outline around the components. It is purely for the identification purposes, and it also prints symbols as well as names of the components. For example, the name of the PCB board is printed here, that is UNO. This is UNO board, so they printed UNO. Manufacturers data like pin numbers, names, logo, like this PCB contains UNO logo. Okay, so any manufacturing data can be printed over this silver screen. So any manufacturing data can be printed over this silk screen. It is usually and in most cases white. Sometimes you may also see silk screen printed in yellow color also. PCB design, as I have said before, it's a science as well as art at the same time. Previously, when there were no CAD tools or when computers were not that popular, PCBs were completely hand drawn. So we have to create a circuit with hands onto a paper, and then a respective PCB design or its artwork design was to be created using a hand drawn method only. Nowadays, mostly almost everyone working in electronics uses computer aided designing tools for developing these PCBs. It's a job of sheer craftsmanship, but with some training and some proper practice, you can easily understand and excel into the PCB designing. CAD tools. What CAD tools we use? Currently our most popular CAD tools that are used are Protel, which is also called Altium Ultimate Designer. This is one of the most popular PCB designing tools available. Then there is Eagle. This is most popular among hobbyists as well as in the open source hardware area. Both of them are commercial softwares. Eagle also provides us with a free tool or a free trial. And next popular CAD tool is Mentor Graphics Pads, which is used by many big companies or big larger enterprises. Mentor Graphics Pads is one of the most costliest CAD tool present there for PCB designing. But we are going to use Easy EDA. It is completely free tool which is web based. There are other free tools also like KiCad. KiCad is also very powerful tool, but for currently we are focusing on to EasyEDA. I have chosen EasyEDA because EasyEDA is the most adaptable and such a tool which can be launched in the least possible time to create single-sided as well as double-sided PCBs. Of course, I have only included those tools which are most popular. There are plenty of more tools also available. Some are free, some are commercial like pads as well as Altium and Eagle. What we have to use is our choice of PCB designing is purely based upon the comfort level. After many years of development, I can say that in our company we can use any possible design software, and definitely that levels come when you perform PCB designing for some significant amount of years. Currently we will be focusing on EasyEDA because it is the simplest, free as well as web based tool. So EasyEDA is free for life. There is no purchasing required. It is a web based tool, so it doesn't require any kind of installation on the computer. All we need is a browser like Chrome or Firefox to use it. There is a cloud space to save the PCBs, so we don't need to worry about saving it onto the computer and deleting it or not finding it later on. We can easily import PCBs designed in the other tools in EasyEDA. There is a large component library available with EasyEDA. I can say extra large because for every component we will find a library in EasyEDA. EasyEDA has an additional feature of built-in PCB ordering system, which can order PCBs directly from the EasyEDA software. And I can say this PCB ordering system is a bit cheaper as compared to our local PCB manufacturers. And coming to the measurement unit of PCB, measurement unit of PCB designing are very important. Generally the most popular and very common unit on PCB designing is TH, which is also called thou. Thou has a standard value that is 0.001 inches, or that is equals to 0.0254 millimeters, or that is also equals to 0.00254 centimeters. This is a standard measuring unit on PCB. So that's all about the introduction of the PCB designing. In the next session we will get started with the PCB designing. Thank you for watching this video.